This video is a follow-up to the one I published on YouTube 2 or 3 days ago on the subject of flying in headwinds and the risk of stalling. And I mentioned the problem of kinetic energy briefly, but I want now to say some more about it because it's quite a complicated thing, but it's easy to explain. You just got to think a bit about it. The question was as to whether when you turn, when you're flying in a wind, whether your kinetic energy is relative to the ground or relative to the air. Now, it's well known and accepted that your, generally speaking, your flight is relative to the air, and it doesn't matter if you're in a wind. If your wind is steady, then you can treat it as being motionless, and what's called an inertial frame of reference, and the plane's movement through the air determines how it flies. But there are times when you have to consider the velocity or speed of the airplane above the ground, or across the ground, because that is affected by the wind, because if you're into a strong headwind, your ground speed is slower, and if you're in a tailwind, your ground speed is higher. And the question is, does that affect the kinetic energy? And the answer is it does, because kinetic energy is relative to, it's a mass question. It's M-A-S-S, mass, not math, not mathematics, mass. The air has very little mass. And the air and aeroplane relationship as far as kinetic energy is concerned is that the plane is the one that's motionless and the air is moving, because it has a lighter density, and therefore it has most of the kinetic energy. This is a principle of kinetics. But in regard to the aeroplane and the ground, the ground has, or the Earth has, much greater mass than the aeroplane, and that is considered as motionless, and the aeroplane is moving relative to the ground. And the question is, when you make a turn, your ground speed changes. So what I'm going to do is I'm going to say, let's take a case of if there's a wind, for example, just to exaggerate it, just to emphasize the point. If you're flying at 100 miles an hour, indicated airspeed, flying in that direction, and you have a wind, a headwind of 100 miles an hour, then that means to say that you're motionless as far as the ground's concerned, and anybody standing on the ground would look up and see the plane not moving. So the question is, would you have any kinetic energy? Now, I want to make this more realistic. I'm going to go through a thought experiment, not something you want to try. I'm going to do this right close to the ground so that you can see that a little more clearly. Let's suppose that you're on the ground in an aeroplane, and your engine is not running, and there's say a 50 mile an hour wind, and the small planes will fly in 50 miles an hour. You're on the ground here, not moving, and so you have no kinetic energy relative to the ground. I won't always say relative to the ground, because when we talk about kinetic energy, we're talking about relative to the ground. We're not moving here, and so there's no kinetic energy. But if we then were to adjust our elevators here, raise the elevator a little bit there by pulling back on the control column, then the airplane would tilt and would then be in a position to fly. So I'll just do that, make the plane getting up in a position to fly with its wings, now with an angle of incidence. Now we haven't, we just got the motor idling. We don't want to go forward, we want to just put a rudder on this plane. By increasing the angle of incidence, the wind then can provide lift. And even without, the engine is just to stop the plane from going forward or backward with the wind. So the plane's going to stay in that location, and it's not moving relative to the ground, except it'll be going up. It can fly. It can lift off the ground, and it can fly. And this has been done. I mean, this is a well-known thing. It's now flying. The airplane is not too pretty. The airplane is now flying, but it has no kinetic energy relative to the ground. It's got some potential energy, but that doesn't affect the issue. It's now motionless above the ground, but it's flying in the air. Does it have any kinetic energy now? The answer is no. But supposing now we're flying now, and supposing we now perform a turn. Don't try this, not close to the ground, because when you turn, the plane loses altitude. You don't notice it so much when you're well up, but if you're just off the ground, you'd notice it all right. You turn the airplane, and you give it a little extra power just to kind of compensate for the fact that you're turning, and you turn around and you go the other way. Now, to do that, of course, remember this air is moving. This air is moving, so you're flying in the air at 50 miles an hour, and you've got your propeller engine and the propeller providing enough thrust to keep you going at 50 miles an hour. And you make a gentle turn. Bank the aircraft with the control column, little rudder, and you turn around and you fly this way. So you see how I draw a left-handed airplane. That's a good, that's kind of funny airplane. You're now flying this way. Well, now you still want to fly, so you're going to be flying at 50 miles an hour in the air, and you're now moving relative to the ground at 100 miles an hour because you're flying. And this is a perfectly feasible thing, but don't try it. You could try it if you were at 1,000 feet, but not 10 feet off the ground. And so you could turn. Now you're flying relative to the ground at 100 miles an hour, flying through the wind at 50 miles an hour, and there's a 50 mile an hour tailwind now. Now, do you have kinetic energy now? And the answer is yes. So, although you're flying through the air in exactly the same way as far as the air is concerned, that is to say, you're flying at 50 miles an hour through the air, but you're now flying 100 miles an hour across the ground, and of course you'd have to be higher because you'd hit a few buildings, and so, but don't try it. Now you have kinetic energy, and this shows you my point that I made in my previous video, but I wasn't too sure about it at the time because it just had occurred to me as I was speaking, that the kinetic energy of an airplane is relative to the ground, not the air, because it is the ground that is motionless, and therefore as far as mass is concerned. But as far as the environment in which you're flying, the wind is much lighter and does not, and therefore that has the moving object has more kinetic energy than the motionless object, in the same way as the moon has most of the kinetic energy in the Earth-Moon relationship, because it is much lighter than the Earth. The Earth is considered as hardly moving. The Earth is orbiting just as the Moon is. The Earth going the other way, but the Earth has only got a radius of its orbit of about 3,000-4,000 miles, whereas the Moon is 250,000 miles. So the moving object is the lighter one. That's the way that you get the balance of momentum and kinetic energy. So the point here then is to make is that kinetic energy is relative to the ground. And this brings me back to the dangers of stalling in wind. And that is that if you are above an airfield, looking down at the airfield now, there's the runway, and the airplane coming in to land here. If there's a crosswind or a headwind, the plane has to have, for a constant speed, it has to have a changing ground speed because of the wind. And when you turn, you must allow the energy of the plane to increase, and that's it's not like being in a car where you can accelerate quickly and get more energy. A plane accelerates more slowly, and therefore make a gentle turn so that your kinetic energy, it keeps up with what it should be relative to the ground. And this is a very important factor in making slow turns when you're in the wind, to give time for the kinetic energy to catch up with you, either to speed up or slow down, as the case may be. The energy equation for energy, as you know, is half the mass times the velocity squared, and that is the velocity of the aeroplane relative to the ground. And so that's an addition to the warning about flying in a headwind, is make sure that you make gentle turns and make sure that your kinetic energy keeps up with your the velocity that you need in order to fly through the air. You have to consider both the air and the ground in terms of your velocity for a safe flight. Thank you for watching this. The previous part of this video was restricted to the effect of the importance of kinetic energy in the flight of an aeroplane. But I'll be doing later videos that give more information about kinetic energy generally, because it's a very interesting subject about why it's the relationship between two bodies, why the equation that we use appears not to have the mass of the Earth in it, although it is included in the sense that the velocity of an object, such as the moon or the aeroplane, relative to the Earth, does depend on the Earth's mass. If the mass of the Earth were doubled, then the aeroplane would and the moon would both have to travel about 50% faster than they are at the moment. So the mass of the Earth is a factor in kinetic energy, but it's hidden in those equations. So I'm going to propose changes to the kinetic equations that do include specifically the mass of both bodies. So thank you for watching this, and look for further videos. Thank you.